Question number 10. Figure shows two blocks connected by a light string placed on the two inclined parts of a triangular structure. The coefficients of static and kinetic friction are 0.28 and 0.25 respectively at each of the surfaces. Find the minimum and maximum value of m for which the system remains at rest. Find the acceleration of either block if m minimum is given a push and it slightly moves up the incline for a short while. So this angle is 45 degree, this angle is 45 degree, so this will be 90 degree. This is mass m, this is mass 2 kg, and here we assume that this mass has tendency to move in this direction, and this mass has tendency to move in this direction, but we assume that there is no acceleration in this case. So tension T will act in this direction, where tension T will act in this direction. Its component of weight will act in this direction, that is mg sine theta. And let's write 2 kg as capital M. So here its component of weight will be mg sine theta, where theta is 45 degree, and we can find out the friction since tendency of these blocks are shown in the direction like this and this. So we can say friction for this will act in this direction and friction for this will act in this direction. So now we have to find out what are the frictions for the two blocks, and then we will calculate the value of small m. So let's write the different forces for block small m. So tension is in upward direction and mg sine theta and friction are in downward direction, but body is in equilibrium. So we can say tension minus mg sine 45 degree minus friction is equal to 0. Or we can write T equal to mg sine 45 degree 1 upon root 2 plus friction. Friction is given by mu mg into cos theta, because it here, if this is the block, this angle is theta. So normal reaction will be in this direction. And if this is mg, and this angle will be theta, if this angle is theta. So mg cos theta, this is small m, mg cos theta, this is normal reaction. And friction is given by mu times normal reaction. So it will be mu mg cos theta. So we can say that it will become mu mg cos 45 degree, that is 1 upon root 2. So if we take mg upon root 2 outside, so mg upon root 2 outside, then we will be left with mu plus 1. So this is tension. Now we consider the motion of 2 kg block. Since the tendency of movement of this 2 kg block is in downward direction, so tension and force of friction will act in this direction, and mg sine theta will be in this direction. So in equilibrium state, we can say that mg sine theta equal to friction plus tension. So here friction will be, again we can find with normal reaction. So friction in this case will be mu times mg cos theta, capital mg cos theta. We can put the values. So mu times capital N g cos theta plus t. We further simplify it and keep in mind that coefficient of static friction is 0.28. So I'm deleting this portion. Now we get mg into sine 45 1 upon root 2 equal to mu mg times 1 upon root 2 because cos 45 is 1 upon root 2 plus t. So we again try to get the value of t from here. So t will be equal to, we can take out mg upon root 2, then 1 minus mu will be left. This is equation number 2. Now, this is t equal to mg upon root 2 mu plus 1, and this is t equal to mg upon root 2 1 minus mu. If we equate the two equations, so what do we get? We will get small mg upon root 2 mu plus 1 equal to capital Mg upon root 2. This is 1 minus mu. Now we further simplify. So here g upon root 2, g upon root 2 will cancel out, and we will get a relation between small m and capital M. So small m will be equal to, this will be capital M times 1 minus mu divided by 1 plus mu. We can put the value of mu as 0.28. So small m equal to 2, and m is given as 2 kg, this one. So 2 into 1 minus 0.28 divided by 1 plus 0.28. So this will become 2 into 0.72 divided by 1.28. Now, if we further evaluate it, we will get 9 by 8 kg. So we have got the least value of m. Now, in order to get maximum value of m, we can assume that the blocks have tendency of moving in this direction instead of going in this direction. So only one factor will get changed. The value of mu can be replaced by minus mu in this relation. So we will get m equal to capital M times 1. And when this mu is replaced by minus mu, so it will become 1 plus mu, and this will become 1 minus mu. Now again we put the values. So small m will be equal to 2 because capital M is 2, 1 plus 0.28 divided by, this will become 0.72. So this will become 32 by 9 kg. So we have got small m minimum as 9 by 8 kg and small m maximum as 32 by 9 kg. So this is answer to first part. Now, in second part, it is given that, let's redraw the diagram so that thing may remain clear. Here, this is block M with the least value. This time, M is to be taken as 9 by 8 kg. And here, this block will remain 2 kg. Diagram is little untidy. Sorry for that. So capital M will be 2 kg. And this is pulley. And this is connecting wire. So this block is like this. Now, these angles are same, 45 degree, 45 degree. This is small m, and this is capital M. Now, in our question, it is given that this block is given slight push in this direction, which gives acceleration A. This block will move in this direction with the same acceleration. Tension will remain same. This is tension. This is tension. Now, its component of weight, or its component of weight will remain mg sine 45 degree, and friction will act in this direction. So we can say tension must be equal to mg sine 45 degree plus friction, and friction, as I told you, it is mu mg cos 45 degree. But this time we have to take mu as kinetic friction. So that is 0.25 for graduation purpose. Okay. So here T minus, since force is in this direction, T minus mg sine 45 degree plus, so we write here in bracket. So T minus mg sine 45 degree plus mu mg cos 45 degree equal to ma. So we can write it further. T minus mg upon root 2 plus mu mg upon root 2 equal to ma, or T minus mg upon root 2 can be taken out. Then 1 plus mu equal to ma will be left. Suppose this is equation number 3. Now consider the motion of this block. As I told you that there is tendency of this block to move in this direction with acceleration a, and its component of weight will be mg sine theta in this direction, and friction will be in this direction. So we can say that mg sine 45 degree minus tension minus friction, and friction will be mg cos theta times mu. So mu times mg cos 45 degree equal to capital MA. We simplify it. So mg upon root 2 minus t minus mu mg upon root 2 equal to ma. Or we can do one thing, we can take out mg upon root 2, then 1 minus mu minus t equal to ma will be left. This is equation number 4. Now, if we add these two equations, what do we get? So, on adding these two equations, t will get cancelled, and we will get mg upon root 2 1 minus mu. Here this term t will get cancelled, then minus mg upon root 2 1 plus mu equal to small m and plus capital M times a. Here our concern is to get the value of a. So we can put the values like capital M equal to 2 kg. Let's put the values. Capital M equal to 2 kg, small m equal to 9/8 kg, g equal to 10 meter per second square. So what do we get? We will get 2 into 10 divided by root 2, and mu is 0.25, coefficient of kinetic friction. So 1 minus 0.25 minus 9/8 times root 2 times 10, 1 plus 0.25 equal to 9/8 plus 2 times 8. We can simplify it. 2 into 10 divided by root 2 into 0.75 minus, this can be cancelled. This is 4 times, this is 5 times. So 9 into 5 divided by 4 root 2 multiplied by 1.25 equal to, this will become 16 plus 9, 25/8 times 8. Now we further simplify, and this is only simple calculation that you can do. So we will get A equals 0.31 meter per second square. And that is the answer. Thank you for watching.